In this video, we'll continue with our discussion on BGP communities. Like if you remember in our previous scenarios, we have discussed the BGP communities is a method of adding the tag to specific routes, and based on that tag, the routes get advertised along with that community information. And now the remaining routers, the upstream routers, can either do path manipulation. They can decide what is the preferred exit path to go outside their autonomous system number by using local preference or wait, or we can also do some path filtering or route filtering, where we can also tell that do not advertise this value, whatever is coming with that community value should not get advertised to any of the neighbor. Now there are two ways or two reasons to use BGP communities. Now in this section, we'll continue with our discussion. We'll try to understand BGP community types. So majorly there are two categories of BGP communities. The first one is well-known predefined community attributes, and then we can also define our own attributes. Now when you say predefined means now we already have some community attributes defined and the behavior is also defined, like what exactly they do is predefined. Okay, so predefined. But whereas in our communities, we are going to decide what exactly upstream router has to do with that community attribute. But whereas when in the predefined attributes, what the upstream router has to do with that community is already defined. Let us try to understand the first well-known predefined attributes, and then we'll get into our own community attributes also. Now there are majorly four categories of predefined well-known communities. We have something on no export, no advertised, internet, and local AS. So four attributes. So when you say no export, let's take an example. I'm going to match 10 network and I'm going to add the community value with no export. Okay, so whenever you say no export, whenever a router receives any network with community value of no export, it will not advertise that particular route to any of the eBGP peers. You can see no export means it should not advertised to its external BGP neighbor, but it will advertise to all the routers within the same autonomous system number. Which means now this router receives it, it will advertise to each and every router inside the same autonomous system number, but that update will not be advertised to any of the external autonomous system number. So that is what we call as no export. Do not advertise to external BGP peers, but still it will advertise to internal peers, which means it will keep this information or that particular route will be advertised within the same autonomous system number. Now the next attribute we have no advertise. So when you say no advertise, it will not advertise to any of the internal BGP neighbor, and also it will not advertise to any of the external BGP neighbor, which means so I got a router which is connecting to internal routes as well as external neighbor. Now this route will not be advertised to any external BGP neighbor. Also it will not be advertised to any other router within the same autonomous system number. Okay, so now the difference between these two is this will not be advertised to outside the AS, but this will not be advertised to outside the AS as well as inside the AS. So that is a basic difference. Now when we use another attribute called internet is a default community attribute, which generally by default it will advertise to each and every router. It will advertise to internal BGP as well as external BGP. Now any router by default belongs to this community, because by default BGP will advertise, it receives any route, it will by default advertise to any router. It can be internal or it can be external. And then we have one more attribute called local AS. Now when a router receives any network with local AS attribute, it is going to advertise to only the internal routers, nothing but to all the routers inside the same sub-autonomous system number. Now if you remember, we have discussed, now probably if you're not aware of BGP configurations, I have discussed that BGP configurations in a separate section. Now BGP configurations is the method of creating the big autonomous system number into small autonomous systems. We call them as sub-autonomous systems. Now if any router receives an update with local AS, it will advertise to all the routers within the sub-autonomous system number, but it will not advertise to any other external sub-autonomous system number, especially applicable in BGP configurations. Now these are well known, predefined, because the definition is defined here. You know what exactly it has to do. It is something defined already. we are not going to do anything, we are just trying to use it. Now when this is more applicable is, let's take an example. This is my service provider router. Now you may come across a scenario where you are receiving some network, 5 network, and you want this network to advertise to a service provider, but this network should not get advertised to any other customers. Let's say these two are different customers. Now what I'll do, I'll add an attribute called no export. When I say no export, it will be advertised to all the routers inside the same AS, but not advertised to any external autonomous systems. So in this kind of scenarios, we can use no export. Now when we use no advertise, now you may come across a scenario where you are advertising some prefix to service provider or to another autonomous system number, and you want to ensure that this advertisement should not get advertised to any of my internal BGP neighbors, also should not get advertised to any external BGP neighbors. Now in this case, what I can do, I can simply say no advertise. When you say no advertise, it will not be advertised to any internal neighbors, also it will not be advertised to any external neighbors. So it's an easy way of tagging and also easy way of filtering the BGP updates. So there are many other ways, like you can use ACLs, prefix list, to filter the routes, but we can also use the BGP communities to filter the routing updates by using this predefined well-known community attributes. So the next thing we'll see, the second category of the attributes, we have something called our own communities. So when I'm saying own communities means, what I'm going to do is I'm going to match a specific network and I'm going to define my own value. So I'm going to say community value 200, which means this number, it doesn't have any predefined behavior. Now it's up to my requirements. So what I can do is I can advertise to all the routers, and now this router can decide what it has to do with this community value of 200, whether we want to do some filtering, or you want to advertise, or you want to apply the local preference, or you want to apply the weight, whatever. So I'm going to just tag my routes, and it's up to you, or it's up to the upstream router to decide what exactly to do with that specific routes. So now to define your own communities, it's a 32-bit number, which means you can use the range of 2 to the power of 32. It's a big range of numbers you can use. Now there are two ways of defining your own communities. The first method is the old method, where you can use any number in between this range. So it is actually an old method of tagging the routes. Any number you can use. I can say 100, 200, 300, 400, any number. So nowadays, most of the new iOS supports the new method of tagging the routes, where you can define in this format. You can say something called 500:10. So this is your 16-bit, this is your 16-bit. Mostly your first 16 bits defines your autonomous system number, from where the routes are originating, maybe the customer autonomous system number, and in that customer autonomous system number you can use any number defined. So this is a new method of tagging the routes. Now still the older method is also supported. Now in case if you tag with this new method, let's say I have created a route map and I have given set community 500:10, by default most of the iOS will still get back to an older method only. Now if you want to change to new method, there is a command called BGP community new format. There is a command called community new format command. Once you apply that command, then only the iOS will start using the new format of tagging. But in today's networks, I generally go with this new method of tagging, but still you can also use the older method of tagging also. So it's a 32-bit value which can be used to tag a specific routes. It's up to the requirement what you want to do with that.